So we're solving system of linear equations in two variables. We saw how to solve a system of linear equation by graphing, and we saw all the possibilities of solution. And these solutions are going to be the same when solving by substitution and by elimination. So we remember that we have three outcomes possible. First is when you have no solution. No solution is when you have a false statement. For example, 0 equals 5. If you're solving, the variable goes away, and then you end up having a false statement, you know that you have no solution. The second consideration or second outcome is when you're solving your equation and you end up with the variable being canceled out, and then you end up with a always true statement, a statement that is always true. In this case, you have infinitely many solutions. Infinitely many solutions. If you have a case like 0 equals 0, 5 equals 5, so you have a true statement, a statement that is always true, or a unique solution. If when solving the equation, you find x and y, and then now you say that your solution is a unique solution, as you have your x value and the y value, and you present your solution set. So these are your three outcomes when solving a system of linear equation in two variables. Now, in this case, when solving a system of linear equation in two variables, your steps are the following. So the step you take to solve are the following. So first, you should solve one of the two equations for one of the two variables. It's your choice to decide which equation and which variable you're solving for. Sometimes one of your variables will already be solved for, so you don't have to take this step. But if you don't have a variable that is already isolated, you first need to solve one of the equations for one of the variables. Step 2, you substitute the expression found in the step 1 for the variable you've solved into the other equation. So basically, you find your equation, you find your equation, and you solve for this variable. Your expression you got from the equation you solved for, you substitute it in the second equation. And then step 3, you solve the linear equation in one variable found in step 2. You solve it, isolate the variable. And step 4, substitute again this value found in 3 into the equation you had in 2, so you can find the exact value of the second variable. Once you get that, then you present your solution. So let's see what is it in this problem. So in this problem, we don't have to take step 1 because we already have y by itself in the second equation. So I'm just going to step 2, which is substitute the expression found in step 1, which is this expression here, y equals 9x. I'm going to plug it into y in the first equation. So that is x plus 9x, because y is 9x, equals 40. And then solve this equation, which is step 3. You're going to solve this linear equation for the variable x. So 10x equals 40. Divide by 10. We got x equals 4. And then now step 4, the x equals 4, you're going to substitute it into the equation that solved y. So you can find the value, the exact value of y, which is now y equals 9 times the value of x, 4. So y equals 36. Y equals 36 is my solution for the y value. And then now we can see that we have the value of x, we have the value of y. We fall into the third situation where we have a unique solution, x and y. So we have a unique solution, which is x equals 4, and then y equals 36. Okay. So then now let's go to the next problem. Number 35. We said it says that we need to solve by elimination. Solving by elimination, we must eliminate one variable. So that's why it's called elimination. Now, in order to eliminate, we need to pick which variable we want to eliminate. And based on the choice to eliminate, we decide what to do. We can decide whichever variable we want to eliminate. If you decide to eliminate the x variable, so then you're going to need to make sure that you manage to have, since this one is 5x, you need to manage to have negative 5x. So to have negative 5x, then I'm going to multiply the entire equation, the entire bottom equation, by this negative 5 that I want to be in front of x. So then my new system becomes, it's an equivalent system of what I had, because I multiplied the entire equation by this coefficient negative 5, which will not change my equation. So then the first one remains 5x plus y equals 19. And then we multiply everything by negative 5x. So by negative 5, so that's negative 5x plus 10y equals negative 30. Okay. Now it eliminates the x term for me by adding these two. I move it down here so we can have more room to work. And then I have 11y equals negative 11. Divide by 11. I have y equals negative 1. And I feel like we're going to have a unique solution case again. If you want, you can perform the same thing now with the purpose of eliminating your y. Think about what you can do if you would want to eliminate y instead of x. You have two choices at this point. You can finish your equation by plugging in y equals negative 1 into either one of these two equations, 5x plus y equals 19 or x minus 2y equals 6. So you can find x, or you can choose this time to eliminate your y and keep your x, and then move on solve this equation to find y? Well, to find x. You can decide either one. But since I want you to see what would that be if I wanted to eliminate my y instead of x, I'm gonna eliminate x, eliminate x, eliminate y, sorry, so I can solve for x. So let's go ahead and eliminate y. To eliminate y, think about what to multiply, which equation to multiply by what to eliminate the y. Pause the video and think. So eliminating y would involve multiplying the first equation by positive 2, because I want something with the y term that is same number and opposite sign, so that when I add the two equations, it cancels out my y. So multiply the top by 2. So that is 2 times 5x plus y equals 19. And then the second one, keep it just like it is, because I'm not trying to eliminate my x this time. So that's x minus 2y equals 6. And the new problem, the new system becomes after multiplying becomes 10x plus 2y equals 38. And then the second one, same thing, x minus 2y equals 6. Then you add, that cancels the y, 11x equals 44. Then we divide by 11. We got x this time equals 4. And you can see that's my x and that's my y. I can go ahead and give the solution. It's a unique solution this case as well. So that is the ordered pair, x equals 4 and y equals -1. That is my solution. The next problem here, still by elimination, they ask me. So to solve this by elimination, I'll do the same thing, but pay attention. Earlier, I see that one of the two equations had the x or the y with a coefficient that is 1. But these ones, x and y, always, all of them have a coefficient. Well, I'm gonna try to eliminate x this time. So to eliminate x, I can multiply the top equation by -3 and the bottom equation by 5, so that I would still have 15 for the coefficient of x with opposite signs. Then my x will be canceled out when I add both equations, right? So then let's do that. My new system, which is an equivalent system because the whole equation, each of them was multiplied by a same coefficient, which didn't change my equation. So that is -15x plus 27y equals 0. And then positive 15x, you see how the x's have opposite coefficient, same number, opposite coefficient will allow the simplification of this. And then plus minus 10y equals, what is 5 times 17? 85. X gets canceled. Then I'm moving on to finding my y. So that is negative 17, positive 17y equals 85. When I divide by 17, I'll get y equals 5. So I have my y value, right? So now I can do both ways, since we can do either find out what to multiply by to cancel y this time, or make it easy for yourself. Just plug in the y into one of these equations so you can find the value of x. I'm going to plug in y into the first equation. So that gives me 5x minus 9 times the value of y, 5, equals 0. So 5x equals 45. I move it over, divide by 5. We get x equals 9. X equals 9. Well, x equals 9. So I go back here to say that's my unique solution. X first, 9, and y, 5. That is my solution. Next up is solving rational equations. When solving rational equations, we must make sure that we go through these steps to solve the rational equations. Step 1, make sure that denominators are all factored. Factor completely all expressions in denominator. I'm not talking about numerator. I'm saying denominator. Now, if they are already factored, that means you have only linear terms, linear expressions, or monomials, or expressions that you cannot factor. Now you move on to step 2, where you find the least common denominator for your equation. Least common denominator. That means it's going to be an expression that you make sure all the factors existing in denominator are included in this expression, so that when you multiply by it, it cancels every denominator. So you can be left with only an equation without denominators, or denominators are all 1. And then you move on to finding your excluded values. What are the excluded values? Well, you know that excluded values are values where of the variable, if you replace them in the equation, denominators will be 0. And you know that we cannot have 0 in denominator. So any value that when you plug them into the equation, that will make the denominator equal 0, or the LCD equals 0, it's called an excluded value. So you need to find them and make sure that you list them in case when solving your equation you get them, so you know that these values are to be rejected. Then take your LCD, multiply the entire equation by it, so you can simplify. And after you simplify, you solve. After solving your equation, be careful. You need to identify all the extraneous solution, because if a value was excluded and found to be a solution, it's automatically an extraneous solution. So means that it's to be rejected. So that are the steps to be taken. Now, these are already factored, right? Because it's one monomial for each. So your LCD is x, there is an x and a 5, so 5x is your LCD. Excluded value, or values, in this case value, is 0. Whenever it's a monomial, that includes the variable, your excluded value would be 0. And now we know the excluded value, we know the LCD. The next step would be to multiply the equation by the LCD 5x. So that's 5x times 9 over x plus 5x times 1 over 5 equals 5x times 8 over x. So let's simplify. X gets simplified. So we got 45. 5 gets simplified. You got x times 1 plus x equals x gets simplified. So that is 45 times 8. Then now we can just add, subtract instead 45 on both sides. And then we got x by itself equals -5. -5 was not an excluded value because the only excluded value we got was 0. -5 is not the excluded value. Then we can keep it as the solution. So my solution set, whenever you're solving equation, remember to present your solution set. My solution set is -5. Next up is this problem. Find your LCD. Since it's just one factor that is the same on both fraction, so that's x plus 1. And now the excluded value is the value that will make this equal 0 is -1. See, if x equals -1, this will be 0. So that makes -1 the excluded value. So basically your excluded values are all the values the variable can take that will make the LCD equal 0. Excluded values are all the values that can make the LCD equal 0, right? So that is -1 here, because if x equals -1, LCD equals 0. Now let's multiply by x plus 1. X plus 1 times x plus 5 over x plus 1 equals x plus 1 times 4 over x plus 1. X plus 1 gets canceled, so x plus 5 equals 4, subtract 5, x equals -1. X equals -1, and then -1 was excluded. Which makes -1 an extraneous solution. So we don't have solution because that's the only solution we'd have, and it was excluded. So no solution. Next, solve this equation. This one we need to factor, right? So my equation is 3 over x minus 21 minus 5x over square root of 41 is 21. So that's x minus 21 times x plus 21, difference of squares, equals 5 over x plus 21. So LCD is x minus 21 times x plus 21. So we make sure that we include in the LCD all the values for which all the factors that are in denominator. So since all the factors are present once for each fraction, so then that's why we have it once for the LCD, and all of them are there once for the LCD. So that said, the excluded value the excluded values are 21 and negative 21. In case we get these values as a solution, we know that we need to exclude these. Now we would multiply everything by x minus 21, x plus 21, and cancel what they have in common. So for the first fraction, x minus 21 will get canceled. Then we would have 3 times x plus 21 minus, both factors will be canceled because that's the LCD and that's the same expression here. So that would make me will end up having only 5x left. And then over here, the LCD and this fraction, they have x plus 2, x plus 21 in common. So x plus 21 will be canceled, and I'm left with 5 times x minus 21. Then I'm going to distribute and then simplify and solve. So let's distribute. That's 3x plus 63 minus 5x equals 5x minus 112. Is it 112? 105. 21 times 5. Negative 105. And then we can combine like terms. That's negative 2x plus 63 equals 5x minus 105. Subtracts 5x on both sides. Negative 7x plus 63 equals negative 105. Subtract 63. Negative 7x equals negative 168. And then divide by negative 7 to get x equals 24. So 24 was not one of the excluded values. Now I get my solution that is 24. Let's play with this one here. So this one is, we need to factor because I see a difference of squares in denominator. So let's see the LCD, I mean factored form first. 2 over x minus 1 equals 4 over x plus 1 x minus 1. LCD is x plus 1 x minus 1, which makes the excluded values 1, negative 1, and 1. Those are the values to watch after we solve the equation to see if they are not there as a proposed solution, right? So let's multiply. When we multiply this one by LCD, x minus 1 gets canceled. I'm left with 2 times x plus 1. Multiply this side by x by the LCD, both factors get canceled. Then I'm left with 4. Distribute 2 to x plus 2 equals 4. And then now we would solve this. See if we can solve it right here. We'll solve this to get subtract 2 on both sides. 2x equals 2 and divide by 2. X equals 1. Well, x equals 1. 1 was an excluded value, right? So then the only solution I have was excluded. Then I have no solution for this equation. I have no solution for this one equation. Next up, we should factor first. So that is 64 over x plus 4x minus 4 minus 3. I put a 1 to make sure that this is not without denominator. Denominator is 1, which will not affect in any way my LCD, but still, just so you remember that. And 2x over x minus 4. All the factors must be included in my LCD. So LCD would be x plus 4, x minus 4. That would be enough to cancel everything, right? So then when I multiply this one by the LCD, cancels everything. I'm left with 64 minus 3 times, well, I'm going to have to multiply 3 by everything. X plus 4, x minus 4, which is the same as x squared minus 16, right? And then that equals to 2x that multiplies the LCD, but the LCD shares a factor with this fraction, so that one gets canceled. I'm left with 2x times x plus 4. And then what's next would be we need to solve this equation. Well, let's distribute 64 minus 3x squared minus, that's plus 48 equals 2x squared plus 8x. Now we're going to try to have the equation into zero this equation out. We want to make sure we do that because it's clearly that's going to be a quadratic equation because we have x squared. Now we're going to move all the terms on one side. I want to keep these things home and move everything else over here. So that will make it, when I move this over here, it'll be plus 5x squared. And combine these two, 64 plus 48. 64 plus 48 is 112. So that is 112 and plus 8x. So plus 8x minus 112 equals 0. We forgot to mention that excluded values are 4, -4, and 4 in case we got one of them or both of them as solution. We never know. So then now let's go ahead and solve this quadratic equation. Let's see if we can solve it by factoring. We multiply 5 and negative 112. That is 5 times negative 112. That's negative 560. We need two factors of negative 560 that the sum is positive 8. Well, we're going to do some work. We can start with, I don't know what you want to start with. 2 times what equals that, and keep going. The values are 20 and negative 20 and positive 28. These are the two values. Well, obviously, you're going to check and try to find the right values until you get them. I tried outside of the video and I know them now because I don't have enough time to do all the checks in the video. All right. So then break it down, break the middle term down as negative 20x plus 28x, right? So that's 5x squared minus 20x plus 28x minus 112 equals 0. Factor by grouping 5x out, so that's x minus 4. Factor by 28 plus 28, x minus 4 equals 0. Refactor out again x minus 4, so that's 5x plus 28, this the second factor. Then we have two values, x equals 4 or x equals negative 8, not 28. Sorry, that's 28. Negative 28 over 5. So this one was excluded. So my solution is negative 28 over 5. Next problem is an equation that has more than one variable that we need to solve for one of them. So since this is all the way inside of the parentheses, we may want to distribute. Otherwise, if the variable you're solving for is outside of a parenthesis, you may not want to distribute. Like if I was solving for h, I would not want to distribute. But since I'm solving for q inside of the parentheses, I would want to distribute. But first, eliminate your denominator by multiplying both sides by 8. Cancels 8, and that's 8a equals hq. I distribute the h plus hz. Now I'm solving for q. I want to subtract the hz on both sides, and then I will get hq by itself equals 8a minus hz. Then divide everything by h to isolate q. Q by itself equals 8a over h. Now we can simplify the h minus z. So that is your solution. That's the expression for q. The next three problems will be about solving by using a given rate. So how these equations are set up is that they give you information for one situation, and then they give you one missing information, and you're gonna create rational expressions and then try to find your solution. So let's read this problem. A camel can drink 15 gallons of water in 10 minutes. So that's the information we have. We know that if the camel is drinking water in 10 minutes, it's already 15 gallons gone. Now, use this as a rate. To use it as a rate, we need to write a fraction that has this information. My first fraction, 15 gallons in 10 minutes. So I see this information, but you need to use your units very wisely. You see how 15 gallon is on top? Now, whatever you're gonna call gallon, it's still on top of your next equation. It'll be the same rate. Now, at this rate, that's why we can set it equals to how much water. Call it X, so that's X gallon that I don't know yet, but I'm gonna find it because you see how gallon is on top, gallon is here on top as well, because that's what they want me to find. At this rate, in 2 minutes, how much water this camel will drink? So that's going to be 2 minutes. Well, I don't really need the minute gallon information anymore. So now I know that I need to align them. And then my result will be in gallon because that's what they wanted me to find, right? So basically it's 15 over 10 equals X, which is the number of gallons in 2 minutes, over 2. Cross multiply. So that's 10x equals 30. Divide by 10 to isolate x. So x equals 3 gallons of water. The camel will drink in 2 minutes. Here's another similar problem. In 2005, 11.9 out of every 50 employees of a company were women. If there are 49,950 total company employees, estimation, because 11.9 is not really a realistic number for a number of people. That's why they talk about estimate. The number of women would be in amongst this 49,950 people of the company. Well, same thing. 11.9 women of 50 is X number of women for 49,950, right? And then we cross multiply. So that means X, 50X equals 11.9 times 11.9 times 49,950. So basically, if you divide by 50, you would have X equals 11.9 times 49,950. So that X equals 11.9 times 49,950 divided by 50 is 11,888.1, but we estimate this to be approximately 11,888 women. And then last problem, a giant tortoise can travel 0.17 miles in 1 hour. So 0.17 in 1 hour. And it says, at this rate, how long? They asked me for the time, so X would go in the denominator because that's 1 hour and the time here. They need to be aligned. How long the travel would be in 2 miles. So that's 2 here. Then cross multiply. 2 times 1, 2 equals 0.17x divided by 0.17. So X equals 0.7 2 divided by 0.17. So that's X equals 11.76 miles in 2 hours. So that is the second part of your review.